same base equaling 1 log with the same base, then you can just say that's the same. I can set x equal to y. All right? So when you see something like this, you can't just say, oh, I'll just make all the logs go away and get x plus 2 equals this, because this is more than 1 log. Okay? So you have to pay attention to that. But do we have a way that we could take 2 logs that are added together and put them back together as 1 log? Multiplication, yes. Addition goes to multiplication. So again, that's where those properties are so handy for us. Addition goes to multiplication. So the first step here is I can rewrite this as log base 2 of x times x plus 2 equals log base 2 of x plus 6. Now you can use this property. So you want to set these two equal each other. I'm going to mark Kinzer after that. Is it okay if I multiply this and get x squared plus 2x equals x plus 6? This is also different than the ones we did yesterday, because now how am I going to solve this? It's a quadratic equation, so we could factor it, we could complete the square, we can do the quadratic formula, because yesterday we didn't have any quadratics. So I'm going to get it equal to 0, because factoring is my favorite thing to do. So I always look to see if I can factor it first. And if it's not factorable, then I would do the quadratic formula, or I would complete the square. But I think this one is factorable. Well, multiplies give me 6. That subtracts to give me positive 1. 3 and 2, we have negative 2, positive 3. 3 times negative 2 is negative 6. 3 minus 2 is positive 1. If you're terrible at factoring, quadratic formula always works. But this, I think, is much faster. Set each one equal to 0, and do agree I get x equals negative 3 and x equals 2. We didn't really talk about this yesterday because we didn't have any problems like this. But remember that logarithms have a very restricted domain. And so you really need to always look at your answer and make sure when you plug it into the problem that you don't get 0 or you don't get a negative number. Because remember, a logarithm will never equal it'll never be log base whatever of 0, and it'll never be a negative number. So you can have extraneous solutions. Most of the time is when you get more than one answer. One of them doesn't work, but it really could happen any time. So you just want to kind of take a quick look. Negative 3, when you plug that in for x, that would make that undefined. So that answer would be extraneous. And 2 would work in all of those. So the answer there would just be x equals 2. So make sure you look out for that. Technically speaking, that can happen on any problem. If you get a number, when you plug it in and you get a negative for the logarithm there, or 0, you would have to say that that doesn't work. Okay? Questions about that? That one's not so bad. Okay, you ready for the bad one? This one's kind of crazy. What do you think we should do first in this problem? Yeah, definitely, let's make it not a fraction. This is ugly enough as it is. So I'm going to multiply both sides by 2. And when I multiply this side by 2, the 2's cancel. And I'm left with 2 to the x minus 2 to the negative x equals 6. And now this is one that, I wrote in my notes when I did this wow next to it because I had to go in the book and look and find an example and see how they did it. There's one in your homework like this, except for the numbers are different. And I don't expect that probably you would have been able to figure it out on your own, which is why we're going to kind of do it together tried to log both sides or ln both sides, nothing's going to work out because of this subtraction, all right? It really like doesn't fit any of the other types of problems. So what I'm going to try to do is make it into something that I can factor. And again, you might say, well, why would you ever do that? Well, only because I looked in the book to see how to solve it. So just like I can e both sides, just like I can ln both sides, I'm going to start by multiplying both sides by 2 to the x power. And again, I didn't know how to do that until I looked in the book. And now, when you see a problem like this, every time it's going to work. Whatever number you have there, you can do this. And now let's see if we can think how to do this. Ty, stay with me. What would 2 to the x times 2 to the x be? Let's take a little sidebar here. This is my little, using other algebra that we know how to do to think about how to do this. If I have x times x, what do I get? X squared. If I have 2 times 2, we know that's 4, right? But if I was going to write it as 2 to the what would I write it as? 2 to the 2, right? When you multiply things with powers, let's even go this. 2 to the third times 2 to the fourth, you don't change the base. The base stays 2. You just add the exponents, like 2 to the third times 2 to the fourth is the same as 2 to the seventh. X times x, you just leave it x, but you add the exponents, right? So now, if I'm going to take 2 to the x times 2 to the x, I'm not going to multiply the 2's together. That's going to stay 2. And then once x, that's going to be x squared. No, that's not right. What do we do with exponents when we're multiplying with the same base? Do we multiply these two? You add them, right? So 2 to the x times 2 to the x is 2 to the 2x. It's kind of weird, right? You add the exponents. It's just weird because the x is in the exponent. So now, let's go a little bit further here. What would be 2 to the x? Well, I'm just going to go ahead and put the minus sign there. 2 to the x times 2 to the negative x. We're adding the exponents. What is x? X plus negative x would be 2 to the 0, which would just be 1. Yes, you're adding the exponents. And on this side, you can't do anything there. We have to just write this as 6 times 2 to the x. And you might say, this doesn't look any better. It looks actually worse than what we had to begin with. I'm going to move this over, and I'm going to get it equal to 0. And let's see if maybe we can kind of see what's happening here. So I have 2 to the 2x. I'm going to put this in the middle. Minus 6 times 2 to the x. And 2 to the 0 is just 1. So I end up with this. Does that look like anything that we've dealt with before? Like the same kind of setup as some other thing that we know how to solve? Kind of looks like a quadratic, right? It kind of looks like a trinomial that maybe you could solve that somehow. Again, let's sidebar this.
I have one question.
Yep.
Okay, how can we multiply by 2x?
Because it's the only way that we can solve this. I don't really have a good reason except for when I found the example in the book, that's what they did. And so the only way that we can make this a problem to solve is when you see something like this, you're going to multiply by whatever that base is. And it's just one of those types of problems that we do one, and then when you see one like it, you just follow that same example. There's no other thing to do here. I guess that's another thing to say. We can't separate it. We can't get the x out of the exponent. And so actually what we're trying to do is make it fit quadratic form. So let's see if maybe we can sort of remember doing stuff like this before. Do you remember in Algebra 2, we would have stuff like this, like x to the 4th plus the 3x squared plus 2. And we called that a quadratic form, like it fit a quadratic, but we did this two ways. You could do u substitution, or you could just say what multiplies together to give me x to the fourth. I'm not a big fan of u substitution, but I'm going to see if I can remind you how to do this. Do you remember, like we would look at this and we would say, well, if u equals x squared, I could write this as u squared plus 3u plus 2. Any vague memory of that whole u thing? And like when we first started it, we always did u, and then we kind of just, I don't know, I definitely stopped using u. I just would work it out. And then I could factor this into u and u, 2 and 1. But then you had to go back and plug in what u was, right? So that's kind of what happens here. It's just really weird. You know what my u would be in this problem? 2 to the x. So if we wanted to do u substitution here, if u equals 2 to the x, think about this. You could separate this as 2 to the x all squared. That's the same as 2 to the 2x. So you could substitute in here u squared minus 6u minus 1 equals 0. Kind of sort of with me on that? See, the only way we're going to be able to solve this is to use this whole quadratic form here. The worst part about this is not only is this bad enough on its own, is there anything that multiplies to give me 1 that subtracts to give me 6? So I can't factor this. What do I have to do? A quadratic formula or complete the square.
Is you just like the common one?
U is just, we're just substituting in so it looks like a quadratic equation. U is whatever you need to make it. Like in this case, if we were solving this, we would say u equals x squared, because we could say this would be the same as x squared squared, so that'd be u squared 3u plus 2. So it looks like something we've dealt with before. That's why we use u substitution. I think I'm going to make this add a page here so I can solve this. I'm going to do the quadratic formula here, which it shouldn't be that bad, but then we'll see what else we have to do here. So if I do the quadratic formula using u, instead of x equals, I'm going to say u equals negative b, 6, plus or minus the square root of b squared, this is a, this is b, this is c, what's that going to be? 36 minus 4 times 1 times negative 1, all over 2 times 1. You with me there?
And there's one like this one.
There is. And the nice thing is, you can just follow this example. It's just a different number. So I get 6 plus or minus, that's going to become 36 plus 4. Do you agree with me on that? So I get the square root of 40 all over 2. This is where we tend to break some math laws sometimes when we do quadratic formula. What does 40 break down to? Okay, that's the square root of 4 times the square root of 10. So that would be 2 square root of 10 all over 2. And then we can kind of break that up, right? 6 divided by 2 would be u equals 6 divided by 2 would be 3 plus or minus 2 radical 10 over 2 would just be radical 10. You with me on that? If this was just a quadratic and not this crazy 2 to the x, those would be our solutions. X equals that and we would be done. But here's where u substitution has an extra step. We don't want to know what u equals, we want to know what x equals, right? So just like over here, we'd have to plug back in that this u is actually x squared plus 2 and x squared plus 1 and solve it. We have to plug back in what u was. And what was our u in this case? 2 to the x power equals 3 Do you know how to solve that for x?
You have to break it up since you have a plus and minus.
We actually have two problems here. We have 2 to the x equals 3 plus the square root of 10, and 2 to the x equals 3 minus the square root of 10.
You get L on both sides and clear x4, and then
It's kind of like,
3 radical 10 things together for L, and then you
Yeah.
divide it.
it's super exciting, right? But you're exactly right. We can ln both sides or common log both sides because we can pull that x in front. So if I ln both sides, I'm going to put this in parentheses like Lindsay was saying. That 3 plus the square root of 10 is stuck together. Like that's all ln of that. I can bring that x out front. And then I could divide by ln of 2. Are you okay if I do that kind of all in one step or not? X ln of 2 equals ln of 3 plus the square root of 10. So if I want to solve that for x, I get ln of 3 plus the square root of 10 all divided by ln of 2. You can use your calculator from there. You can get an answer. Ln of 3 plus the square root of 10. Close the parenthesis. Actually, you need to close two parentheses if you're using my calculator, because you have to close the square root and the ln. Divided by ln of 2. And I got 2.623.
On the negative or minus the squared one, that one said domain error, so it's like whatever the thing is for radical 10, is it like it's
Bigger
gonna
than
be-
3?
Yeah.
Yes, and so that's the other thing. Remember we just talked about a lot of times when you do the quadratic formula or you factor, one of them's not going to work. So for me, before I do all this work again, when it's 3 minus the square root of 10, you can just take on your calculator 3 minus the square root of 10, and that actually equals negative 0.1623. And that's why you get domain error, because when you ln both sides, you've now taken the ln of a negative number. So I'm not even going to work this all out because it's not going to work. It's negative, and I can't have a negative ln, so it's only one answer that works here. And although this was kind of crazy work here, you can actually check this. You can plug it back in for that problem, and it does work. And that's crazy, but honestly, there's no other way to solve that problem algebraically than to multiply both sides by 2 to the x, use the quadratic formula, substitute back in, and do the ln stuff. So there's one on your homework tonight, and I expect that you follow these steps, all right? Use these same steps that I did to set that up. You okay, Caitlin? That's as terrible as it gets, really, so that's not so bad, right? The rest of it is just maybe some application stuff. So who has a question about that before we move on? A lot of work. I hope you wrote it all down. And not, sleeping wasn't really the best idea during that problem period.
It's not too bad.
I know it's not. It's just like it. If I wouldn't have done that one for you on the examples, then we would have all freaked out on that problem, and I would have definitely been doing it tomorrow in class. But I don't plan to do that tomorrow in class. I plan to help you with questions if you get stuck on it, but I expect you to use the example I just gave you.
You get an answer, you tell us.
Is it odd, Stephen? Is that one odd?
Yeah.
It's odd, so you can check it. You can actually even check all even ones, because you can just plug your answer back in the calculator. But I would have put it.
Well, I put mine back in, it didn't work for some reason, but then I checked it back.
Maybe just some parentheses issues.
Yeah.
So we solved some problems like this using our graphing calculators before. Like this could be like a population growth problem. We could be asking like when would the population be 150, and you can always graph and figure out where they cross. But now that we know how to solve these equations, we should, even though this is kind of complex, be able to figure out how to solve this. And you said at the beginning of class, I know it was to get the ln by itself. The same thing's going to apply here. fraction, you want to get rid of it. And so let's just multiply both sides by the denominator, or maybe you can even think about just cross multiplying. It's a proportion. You can do that too. But if you multiply both sides by the denominator, it's going to cancel out this side. I'm just going to get 400 equals 150 times 1 plus 95e to the negative 0.6x. And then you have some options, right? It's algebra, so algebra you have a lot of ways that you could do this. You could distribute this 150 in, or what else could I do to get rid of that 150? Divide both sides by it. So it's whatever you want to do. It's not wrong if you distribute. You have a calculator. But for me, I said, well, why don't I just divide both sides by 150 so I don't have to make those numbers even bigger? And honestly, you're going to use your calculator. If you don't even want to simplify 40 over 15, your calculator is going to all work out. 40 divided by 15, I think I could write that as 8 divided by 3 equals 1 plus 95e to the negative 0.6x. And again, there's just a whole lot of algebra going on here. I need to get e by itself, so what am I going to do? Right, I can't do ln until I get that e by itself. So I'm going to subtract 1. I'm going to divide by 95. And then that's how I'm going to get it by itself. So when I subtract 1 from that, that's 8/3 minus 3/3 would be 5/3. And then this is where I talk about rounding off error. Like I always try to get you to don't use a decimal until you have to. So when I divide by 95, you can do a few things. I mean, you could get a decimal. But you could also just write that as 5/3 divided by 95. I could write this as 5/3 divided by 95 equals e to the negative 0.6x. Because any time that you use a decimal, you're not using an exact answer. Does that make sense of what I'm saying there? So I always try to keep it exact until the very end. And now what am I going to do? Now I'm going to ln both sides. And you can type that on your calculator. You can type the ln of 5/3 divided by 95 instead of typing in a decimal that is not exact. And what's the last step you're going to do here? Yeah, right now that's negative 0.6x, so I'm going to divide both sides by that. And honestly, this is where it's up to you on what you do, on how you enter this. I do this all at once on my calculator. That way I always get an exact answer. And I expect your answer to be able to match mine. So if you're going to use decimals throughout the problem, use a lot of decimals. Oh, I should have put X there, sorry. Just getting excited here. On my calculator, I'm going to type in ln of 5/3 divided by 95, close that entire thing up, and then I'm going to divide by negative 0.6. And the calculators that we have now are so nice because it's showing you exactly what you type in. Old calculators, like the calculator that I had when I was in high school, it would have been really hard to do this all at once on my calculator. But these calculators, you can see it. And so I really want you to try to do this all at once. But you got to make sure you're using the parentheses. So like my calculator here, I'm going to do ln of parentheses 5/3. I'm going to just show you how to type this in. My calculator is ln parentheses, and I'm going to do parentheses 5 divided by 30. So that I just put that in the top, and then divide by 95, close the parenthesis, and then divide by negative 0.6. It's the whole thing with calculators. They're very nice, But if you don't put the parentheses in the right spot, you're not going to get the right answer. You should get that x is about 6.738. Did you get that?
I didn't put that extra parentheses in for the 530 when it came out.
That's okay. Again, there's not a whole lot of logarithms in this, right? There's that one point that we had to take the ln of both sides, but really that's a whole lot of algebra. Like, can you get e to the x by itself? And so that's why it's so important that you know how to get those by themselves. And you should have some work with that also. Questions on that? Okay, I got a formula for you. It's kind of wordy. It is in your book. If you don't want to write every word of it down, you can just write the formula part. If you just want to write the formula part, you would start about right here, but you still need to write all of that. One application of using logarithms, using E, is Newton's law of cooling. And Newton has this law that says that an object that has been heated, like a cup of coffee, will cool at a specific rate depending on at what temperature it's put in. So that's why it says an object that's been heated will cool to the temperature of the medium, that means its surroundings, in which it's placed, such as the surrounding air or water. And so the formula is this, and this is what you need to make sure that you write down. The temperature of the object at time t, kind of weird because capital T in this is temperature, and lowercase t is time, so that can be a bit confusing. I will not, you do not have to memorize this formula. If I gave you a problem on a test or a quiz, I would give you the formula, like T of t equals Tn plus T sub 0 minus Tn to the e to the negative kT. So you don't have to memorize this, but you need to know how to use it. And it is in your book. I'm sure it's in a lovely little green box in your book. Yeah, it's not even a green box, but it is under, at the top. It says Newton's law of cooling, and it gives you the exact stuff that's right here, if you don't want to write that down. Really important that you know what these things stand for. K is the constant. Like when we did exponential growth and half-life and all that stuff, K is what I call the constant of proportionality. It changes with each problem. Lowercase t is the time, and it's really important that you know what the other stuff means. Anytime it's sub-zero, think about in our velocity formula, v sub-zero means the initial velocity. T sub-zero means the initial temperature of the object. So whatever your object is when you put it in the water or put it in the room, that's T sub-zero. And then T sub-m, they say that as the medium, that's why it's m, is the temperature of the surroundings. And then the answer that you get would be the temperature, the new temperature after so much time. Okay, so when they give you a problem, there's going to be a lot of stuff they throw at you. Like the initial temperature is this, and the temperature of the room is this, and it was in there for 7 minutes, and this was the new temperature. And so it's really important that we can kind of sort through this problem and solve it. So maybe I'll keep this up and show you the next slide at the same time. Let's see if I can do that. Here is a problem that you would use Newton's law of cooling for. And anytime we're doing like a scientific formula, they always use Celsius. Even though we're used to Fahrenheit, these are normal temperatures of coffee. And so this says a cup of coffee has cooled from 92 degrees Celsius to 50 degrees Celsius after 12 minutes in a room at 22 degrees Celsius. How long will the cup take to cool to 30 degrees Celsius? I don't know if you remember when we did like direct direct variation, they could be like 7 varies directly as 12. Find x when y is this, or whatever. You have to find k first, and then you go back and solve what they're asking, right? It's kind of a variation problem. So if you kind of forget that, remember that first you have to find what k is, then you're going to find whatever the problem's asking. Find what it is asking. It's not an all-at-once problem. Like, you can't just say, plug it in and the answer is 7. Like, you have to do 2 parts. Well, you're going to wait for 1 minute. So here's what I want us to do. We're going to take this equation and plug in what we know. Do we know the temperature after so long? The cup of coffee has cooled from 92 degrees Celsius to 50 degrees Celsius after 12 minutes at 22 degrees Celsius. What do each one of those numbers represent? Like, what does 92 degrees Celsius represent? The initial value. What does 50 degrees Celsius represent? Yeah, the ending value. They tell us. So T of T is 50. What does 12 minutes represent? The time, don't leave, is 12. At 22 degrees Celsius, what does that represent? So you can plug all that in, and then you can use LNs to solve that for K, and then you have to go back and solve it again. All right? So there's one of those on your homework. There's one of those worked out on page 326. So look back at it, and you need to do the second assignment here, which I think is on your assignment sheet. 25 through 37 odd, 38, 50, 62, 64.